devices, and that's when progressive web apps happen. So think of progressive web apps as web application which progresses themselves into native look and feel like apps. They have all the capabilities of a native app. They can run offline, sync data offline, and send notifications and fetch in the background and all of that a native app does. Even access your camera and mic and so forth. So the PWA had a lot of success story. We saw Twitter and OLX and Flipkart and AliExpress, Alibaba, all of them did see a lot of increase in their conversion and increase in performance, increase in engagement, and all of that. It was definitely a success story. But it took a decent amount of time for iPhone, basically Safari browser, to implement the core features that PWA needed, may it be service worker or add to home screen, all things that come within a PWA. But today we are at the state where we can have PWA across multiple devices and OS combinations, even on our desktop too. Well, you might already be aware of what PWA is and what it has done, right? Is that the future? Have we already seen the future? Well, not really. Welcome to Jurassic Park. Yeah, just kidding. So think of this talk more like, hey, I would request you guys to mute your mic if you haven't muted. There seems to be a bit of a disturbance. So think of this talk more like a precursor to the upcoming workshops we'll be having, where we will be diving deep into each of the future features we will be talking in the next few slides. So you don't crack your head on thinking whether this feature is shipped onto a browser, or can I use it by enabling a flag, or when will this feature be out? But just try to get a perspective of what the feature is and how you could apply it in your use case. And when we dive deep in the workshop later on in the upcoming sessions, we will know its functionality and how we could enable and all of those things, right? So this is a sample of manifest JSON, or our app manifest. Most of us are aware of what it is. So this JSON would basically tell your PWA about few many things, like what is the icon that should be when it's added to your home screen, what should be the splash color, what should be the theme color, and what's the short name of your application, right? The interesting thing is we have few more attributes on the manifest. Some of them being like the screenshots, the the related applications, and orientation and things like that, right? But a new field has been proposed that would help us to run the PWA on startup. So the request is like this. So you have an application which is a progressive web app. Basically, it's added to your home screen. But now when your device restarts, you want to kickstart that application, right? So for that, this is the new attribute that's been proposed on manifest. It's called request on install, and it says on request or install have run on startup, right? And then of course the key thing about web is it doesn't try to access any of your privacy features without notifying you. So similarly with this case, you need to use Navigator permissions and query for run on OS login and take the permission, and based on that you decide whether the user gave you permission to run on OS login, right? So this could be a PWA on your mobile device or your OS or anywhere where it's added. So this would help you to solve use cases where your application might want to run as soon as the login happens. Also, if you have tried to hand code a manifest JSON, you know it would involve a lot of attributes, and especially for the image creations, which are specific for devices, like probably you're looking for an Apple device or an Android device, or devices with different resolutions and things like that. So there's this Pwa Compact project that would kind of help you to create that manifest, which kind of fits into all different devices and their use cases. So in this talk, when we are trying to see the future features, we will also try to see few of the tools that might help us to make things easier or use these features. So can anyone guess what this animation is about? It's a pretty famous animation by Jake from Google. Yeah, it's basically the life cycle of service worker. So you can consider service worker as a proxy that sits between your network and your browser, but it's bundled within the browser. So whichever request goes through, it goes through the service worker. So in your progressive web app, you are controlling the network rather than network controlling you. So if you're writing the code to register service worker today, would probably use promises. But if you were to include this within an async block, you would use an await. You would use an await on navigator.serviceworker.register your service worker. But there is also a proposal for top level await that's coming in JavaScript. So which can be a talk in itself on what are all the new upcoming JavaScript features. But if you can focus on this snippet for now, you could just await on navigator.register on serviceworker.register and then put it in a try catch block. And if it goes to the catch, that means it failed to register your service worker. Rather than today, you would be probably doing a dot then and dot catch. So this becomes a bit more concise. It looks as if it is asynchronous code, but it is asynchronous in nature. And we all know the famous add to home screen, right? And you would have experienced a lot of times when you're using a progressive web app, you would be adding to your home screen. There is this prompt which says, hey, go ahead and add to your home screen. But now there are like 3 variants of add to home screen. It can be like a mini info bar, like as we see A, and it can also be on your Omni bar, which says, hey, you already, looks like you already have this. You want to launch it or you want to add to your home screen, and then it could be the normal banner. Right? So we have 3 variants for having our add to home screen. And also on desktop, you would have probably seen things like this. If you're using IRC Cloud or Spotify, you would see the install message on the top. When you do, when you click on that plus and install it, it gets installed as an application on your OS, and it gets launched as a PWA, having all the features that has been enabled on the mobile device. It would emulate here as well on desktop, and it can work offline and sync and all of that. Right. This is an interesting event called before install prompt. You could attach the listener on window for before install prompt. And what basically before install prompt does is whenever the user is trying to install it, like just before the installation, you would have control on it. When you could see what the user is doing, like did they accept it, did they cancel it, or what really happened to that action on the banner, right? So you could also have a button that says, hey, click here to install, then you could trigger this event and enable it. So in this case, what we are doing is we are waiting for the before install prompt and having a defer prompt, which is being set. The event has been set as a defer prompt on window, which can be used later on like this. So after you have the defer prompt, we see if it's not a prompt, then that means the prompt is not available. And if the prompt is available, like we'll probably have the prompt event, right? On the prompt event, we can call the prompt. This will show the install prompt. And when the user clicks on that particular install prompt, we could see what choice was made by the user. So based on that, we could decide whether they accepted or denied or whatever. Also, the other interesting event we have is app installed. This is very important because you want to know whether they really installed it, and this gets triggered after the app is installed. And that's where we basically do some analytics stuff saying, hey, okay, this app got installed. So if you're tracking on number of installation or any other analytics stuff you have to do, you can do it here. So if you have added a few of your PWA to your home screen, have you noticed this problem of having a transparent PWA icon that kind of appears inside a white circle on Android? Yeah, I presume few of you would have noticed that. So the next thing that is coming, or it's already being shipped in parts, is maskable icons that kind of instead of having a white circle like this, we would have a maskable icon that kind of covers the entire sector instead. So it looks much cleaner and neater, right? So how are this basically a shift? So you could track these issues on GitHub too, on few of the related projects. Most of them are either on W3C or they might have their individual repos. Here's an example from an issue that was closed in February 2017, where they were talking about icon shapes and masking. But the same thing was again reopened with a different context in 2019 for custom padding for maskable icons. Right, that's when we finally have something like a maskable icon today. And we also have this maskable.app, which is an editor which helps you to create maskable icons. So suppose you have your PWA, SVG, or an image, you could add that image and set the background, set its padding, color strength. Should it be circular, square, or should it occupy minimal surface area? You can shrink it, shadow it with a ghost image, do whatever you want for your icon, and then you can use it. So this is a very cheeky app and pretty useful. The other thing that you probably would have seen and experienced on native app is badging. So by badging, I mean you would have seen some, if you have a notification on your Twitter, say, then you would probably have a small icon indicating that, hey, you have 500 notifications. Something like this wasn't possible on progressive web apps. And today we have the set badge API on Navigator that can help us to set particular text or content on as a badge, and it also has a neat promise-based interface where you can set a badge and catch if things doesn't work out, and we could see what happened, what was the error, and we could also clear the badge based on a particular use flow. Say the user tapped on it and read the notifications. Now you need not have to show that on the badge anymore, so you could clear the badge as well. So most of us would have been aware of push notifications. Here's a quick demo if you aren't aware. So when you send a push notification, basically it appears like that on browser. You would have seen many push notifications on native apps, and PWA had it from the very initial days. But something got better with inline replies, and we could also add images. And here's how the API looks like. So from your service worker, like when it's on the ready state, you could just say service worker show notification with whatever your message is. In this case, it's a new message, and you could say like say Hemanth says hello, and action would be like reply, text, and title and placeholder, and you could do everything that the native notification looks and feels and behaves like. You could also have like two buttons like to like and dislike or accept and reject, and you could get all of those actions on and inline replies, and also have images like icons with the notifications for meaningful context. The other interesting API which we have here is the notification triggers. So with the notification, what happens is at times you might have to trigger a notification after some particular amount of time. And that time might be related to probably you're fetching some information, or you're downloading something, or it is some time-based activity, right? So for that, we have this attribute called as show trigger, to which you can do a new timestamp trigger and pass in the timestamp. Like this is kind of scheduled for 30 seconds. So let's try to quickly see a demo. Yeah, that. So instead of 20 seconds, let's kind of keep it as 3 seconds, and we schedule the notification. After we schedule the notification, we can also list. We saw that the notification has appeared here on my right corner where my cursor is, and it says triggered from, and we could give the message. It's just like any other notification, but we kind of timed it, and we can also list all the notifications, and it works beautifully. So here's a quick demo of a feature called as background sync. On the left, we have this app called Emojoy, where you can just communicate in emojis. Paul Kinlan there on left in the demo is sending some smileys, and Jake on the right is receiving those smileys, and he sends some cycle emojis, and that works fine. But now on the left, we see on the mobile device, we go into airplane mode. And after we go into airplane mode, that's like being completely off the hook, right? And then we go and basically kill this emoji app. We even remove it like from our list. So we try to send a cat emoji to make sure that like we are offline, and like it's just says sending and nothing is received on the right hand side. That's the other client. And now we list the app and kill it. So it's nowhere there in the picture, right? It's killed. And now we go back out of the airplane mode and we connect to the network. So you remember we had sent some cat smileys, right? So it appeared now. The app is nowhere in the foreground or the background. It's kind of killed, and now we kind of send some say evil emoji from the other client, and on the left side we get the notification, right? This is how the background sync API works. Basically, it kind of listens and knows, the service worker knows like when the device is off and on the hook, and you can also queue. You can have a queuing mechanism. You can control it totally on what needs to be done. Like after you get an background sync event, do you want to show a notification, or do you want to clear a cache, or it's totally under your control. So you might be aware of background sync. It's been there for quite some time now with AWS. But here's an interesting thing called as periodic sync. The concept of periodic sync is, say you have an API. Say, for example, your application is cryptography or cryptocurrency app, which kind of shows you updates on the currencies that you are interested. And sometimes what happens is like you might probably have killed the app or put it in the background, but you want to periodically sync the application to get the information and keep it updated. Or say you have written an interesting app that kind of fetches images. This I did recently for one of the demo apps to fetch an image from uh, SpaceX or like Usplash, and fetch it periodically and kind of change it as an wallpaper for your web application. Here's how the code looks like. So it's the same thing again. In this case, we're using just the await syntax within the async function. We say await navigator service worker ready, and once the service worker is ready, we say dot periodic sync dot register, and you can give your name of that registration. In this case, it's image of the day thing that I had used, and this is one day. So every day, the app kind of updates itself with a new image from a particular endpoint. So basically, whenever you're making a fetch to that endpoint, you kind of trigger this image of the day sync. So it kind of periodically syncs for the interval that we have suggested, and rest is under your control to. In this case, it was just to show the image or update the image in the cache. So whenever the network hits that endpoint, it goes to cache using the cache first strategy of service worker, and it would fetch the latest image. The other interesting feature is background fetch. We did talk about background sync. Background fetch is pretty similar. Here is another example of a media player, which has a lot of playlists, which has a lot of videos in it, which you can download. So you can click on download and still you could close the app, but it would still be downloading it in the background. As you can see on the right, it also has two actions of pause and cancel. So think of scenarios of having a media player or a torrent client and similar things where you want to give a feature for the user to download it and just like go to the background and not to worry about it. And after the download is completed, it will kind of give you a notification. It's also done on the service worker, and same with the same logic. After the service worker is ready, we say like background fetch dot fetch, and we would give it a name and then say the resources that it needs to fetch. Then we can give it title, icon, and the download total size, and it kicks in the background and does the required thing for us. We also have two interesting events on the background fetch, which is very useful because suppose you're trying to download and there might be many reasons that the download might fail. The server stopped to respond, or the client kind of timed out, or It might be many reasons. So if you want to catch it all, you could just do background fetch fail, and you could look into the inspect the event and see what happened and show a notification. If the background fetch is successful, you get an event. From that event, you get the registration. You take the registration, that gives you the background fetch, and you wait until you kind of open up your cache on the background fetch ID, which is this unique ID, which kind of gives you a cache, and then you would like match all to get the records. And for each record, you put the request and the response body to the cache, right? And then you await on all the promise. And finally, you will use broadcast channel to send a post message to the client saying, "Hey, look, I've got all the resources what I want, and it's in the cache." Right? And then the client could do send a notification or do whatever is required for the flow. So this is a really cool feature of background fetch. The other interesting feature which we have been using on native and very much used to this feature on native apps is sharing of context to an application, or if you can say it as an inter application communication, right? Say suppose you're on a page on the right side. Now you want to share when you click on the share this page, a drawer appears with all of the application that you can share to. But the interesting thing is there's this thing called a share target where you can say, hey, as a PWA, I want to receive the shared item, right? Now, if you can see here on the image, we have the share target test. So this is a PWA which can receive what's being shared from here, right? So what do we mean by receive and what does it receive? So that's how you kind of define in the manifest. You say, hey, this is my share target. My action is share HTML. My params are like title, text, URL, right? And that's like name, description, and link. And because you mentioned your action is share HTML, in your share HTML, you say, hey, my location.toString, I will probably just look into what's there in my address bar. That's my toString from which I got my name, description, and link. And that would be triggered on onload, right? So that's how kind of share targets work. In 2017, I had created an issue saying that on native apps, we had an option to provide app shortcuts on long press, right? Normally, like for example, in this case, map apps, when you click on map for a few seconds on a long press, you would get an option which says work and home. Similarly, on the same timeline, a few of them had proposals for the same feature, and today we have it as shortcuts. This kind of came to production like 2 days ago, and this is how shortcuts basically look. So in shortcut, you kind of give the name, description, URL, and the icon, and then like you can give multiple shortcuts, and each of them can point to a particular URL. For example, in this case, this Twitter is a PWA, and when you do a long press on it, it has been registered with these shortcuts. So you have a new tweet, explore, notification, direct messages. All of these are basically URLs. And when you click on that, it opens the same PWA with that URL. Isn't that a cool feature? The next interesting feature I want to talk about is Webrtc. So let's quickly see the demo. In this case, we are just entering a phone number and we hit verify. And we did see that it showed that particular device, that particular OTP digits that came in as a request. So let's just pause at that point. So see it. Yeah, so it did say OTP is like 12345 6, right? And after that, as I said earlier, in browser, for every action that is trying to access your private data, there is always a permission thing happening, right? So it's as like allow Chrome kernel to read a message below and enter the code. You say allow, and then it go ahead and enter. This is a basic use case that was missing from a pretty long time for web and in general. But today we're able to achieve this with the OTP API, so Webrtc. So why is this a basic use case? In most of the countries, we have this 3DS authentication that happens, right? When you're trying to do a transaction or trying to use a card, normally you get a two-factor authentication where it says, hey, here's your OTP. After you enter your PIN and CVV, it might ask for an OTP. And some of the applications have only mobile-based logins. That is, they just use your mobile number and a login, let you log in instead of using an email ID. In that cases, a feature like this would make it frictionless and give a very great experience for the users. So this is how it basically works. You do an await on Navigator credentials, which is another set of API. So there are many APIs around, and I've picked up few APIs which are like interesting and are coming in the future or just landed. So some of the APIs are old and probably you might have overlooked it. So I would suggest you to go and check it out again. I'll share the links and content. So in this case, when we do navigator.credentials.get, we can say we are trying to get an OTP, and the transport is SMS. It can also read MMS if people are still using it. And on abort control is another API which kind of helps you to signal and say, hey, this particular event got cancelled. Suppose you're probably saying you can use abort control along with fetch, and you're trying to fetch an API. As we spoke in terms of, say, the background fetch that was happening, when the user kind of clicks cancel, saying, hey, no, I don't want to download this, then you could use an abort signal, abort controller, and cancel that request. Right now, using that, you could say, I need to fetch my OTP, and because you have an abort controller which has a set timeout of these many milliseconds, and then it kind of aborts. That means if the OTP doesn't arrive in these many milliseconds, then go ahead and like cancel this request. That's what it's meant for, right? OTP is basically one-time password, so it has a expiry set to it. So if you don't get an OTP that's generated on the server within that period of time, then there is no point of using that OTP later on. So that's where this is a beautiful API, and it helps and solves a lot of use cases. There's also this proposal of Navigator SMS, which works pretty similarly, and you could have promise-based API. You could SMS.receive to get the content. The other interesting API that we are looking at the screen as of now is the contact picker API. So this is also a very basic use case on day-to-day native app usage, right? So basically what this API does is it helps you to not only open the contact drawer, but also select contact, but that's why it's called as contact picker, right? And select contact and also parts of the contact. Like you can say, hey, I want the name, email, and phone number, or I want just the name and email, or I just want the phone number. So you can choose what you want from the API as a parameter. And that would instantly open up the contact drawer, and you can also limit it to, they have to select just one, or they can select multiple, and then it gives you a JSON at the end with all of the selected contact and the information. So that's what is happening here. Like two contacts are selected, and the key thing to bear in mind is with this API, you need a call to action. Like you can't just trigger it without a call to action. By call to action, I mean like you could have a button or any action, user action that user interaction that happens before triggering this API. So this is how it looks. Pretty simple. And in the props, in this case, we are mentioning name, email, telephone, address, and icon. And as I mentioned in the options, you say multiple true. That means they can select multiple contacts with just name, email, telephone, address, and icon. These are the attributes that they need to select. And then you say navigator.contacts.select props and ops. And then you have contacts, and you can handle it and take over the contacts, go through it. You want to put it in a DB, or you want to send some messages to them, or you could, based on your use case, you could manipulate the data and work on it. The other key interesting feature is the file system API. So what basically this does is this allows you to read and write from the file system. That is really cool feature that the browser kind of lacked for years, right? Yeah, we were able to download files. It would have probably go and sit in a particular directory that's been configured. But how cool would it be to read and write to the file system directly? So in this case, we see an example here on the right side where we have files plus. That means it's saying that this PWA is accessing your file system. And then if you want to like save changes to that particular file that's been the permission has been granted to write into your documents directly with this file, and you could save changes. The browser can now read, edit, or delete, or do all the file operations, and it's directly talking to the file system. This is a cool feature, especially if you say if you're writing a WASM application, or if you're writing a normal web application that kind of wants to operate on your, say, tens and thousands of audio files, for example, that you're processing, right? Now you drag and drop a couple of audio files to your browser, and now the browser can say you're modifying, trimming the content, or increasing or decreasing the pitch, and you want to write it back to your file system. Now the browser has the capability to not only read, write, like basically work on the file system directly. So it's also a call to action kind of a thing. So you have a button to open the file. When you click on that, you could say, this is also a promise-based API. So you could say await window.choose file system entries, and that will kind of give you a file handle. From file handle, you can get the file. So you got the file, and from the file, you can get the text. Now you have the content. This is for reading the file. And if you notice, all of them are promise-based and very intuitive and neat. And for writing files, you do a similar thing, and you'll wait on the file handle to create a writable, and from that writable, you write the contents and close the file. Something like this was like dream few years back and for a long time, and now we have this capability, which is like really awesome for web. The other interesting API I'm going to talk about is called as get installed related apps. If you remember at the very beginning of the slide, I was showing you the manifest attributes where there was related applications, right? So what basically related application means and how this works. Suppose you have an PWA, and there is also, say, a native app for the same PWA. And in your manifest app, you are going to say, hey, this is my related application. My platform is Play, and my ID is this. Now, when you call this API, it would resolve to that particular application. And if you want, you could open that native app. So think of it as not like a kind of a competition or a war between PWA and native. It's about solving the use case and what solves your use case. And web is now capable of doing like almost all of the things that the native does, and it can do it better at times. In terms of size, it is good. In terms of performance, in terms of sharing, and especially in terms of security. So whenever you're trying to build an application, think of building a PWA first, and I'm sure you'll enjoy the journey, and there wouldn't be any roadblockers. The other interesting API we have is screen wake lock. What basically screen wake lock does is, suppose if you're designing a game and if you want to keep the screen open, then you don't want to lock it on by its default time, right? So suppose on a normal basis on a mobile device, or even desktop, when your screen is idle for some time, and if to save the battery, it just goes to the lock screen, right? Now with this, you could control saying that, hey, this is a game, or probably I want to show some information even though the user is not interacting with the device. Don't lock the screen until I allow you to, or until I suggest you to. So how does the API work? So you have on Navigator, you have wake lock and you request for screen, and then you kind of, in this case, you're releasing it after 5 seconds. So basically you have an event on release, and after you get the wake lock, you wrap it in an async function and say a request wake lock. So it's kind of trying to request a wake lock on the screen, and once the release is happened here on wake lock release, the release event is triggered. So you know exactly when the wake lock was released. If this is successful, the request is successful, then the screen wake lock is active. And in this case, after 5 seconds, release gets called, and then the release event is triggered. So that's how you kind of request for a screen lock. And this API is kind of long awaited by few many folks who are working on streams. So you might have heard about Websocket, which kind of gives you a duplex connection between your server and client, which can send and receive data like once the connection has happened. So it need not do multiple connection request of opening and closing. There is no multiple handshake that's happening. It's like a constant, consider it more like a highway, like a constant, more like a tunnel rather, where it's open and data can be transferred. But the problem that used to occur is there is a back pressure problem. What used to happen is there is a lot of data that's coming from the server, and your socket is still trying to process the data, and there will be kind of a mismatch. So what was needed for WebSocket was basically a streaming mechanism. Let's try to look at the demo first, and then come back to the code. By the time the demo opens, you could just check if your Windows supports WebSocket stream by just saying WebSocket stream in window, and then that means you have the WebSocket stream. And from the stream, you could just read the URL as a stream, like connect to it as a stream, and from the connection you get a readable, and from the readable you get a reader. And similarly happens with the write stream. With the write stream you get the writable when you do a get writer. So you get a writer basically. And let's see a quick example. So the first one, what we are seeing here is WebSocket stream. This is an example where we are going through the Wikipedia recent changes and trying to fetch it from the API, and we are streaming it on using WebSocket stream. Here we see it's like so smooth, and there is no back pressure or there's no crazy thing that's happening. But if you're here down here, it just uses WebSocket and not WebSocket stream, you can see the jang that's happening, right? It is like taking, it's not a smooth experience, and there is some kind of a back pressure that's getting generated with WebSocket. And that's where this API really wins for all the socket and socket streaming based applications. We still have a few more interesting APIs. Here in the demo, we are seeing that the user is tapping on those cards. This was one of the Chrome Dev Summit demos. And the card color is recognized by the device by just tapping on it, and it shows what emojis are behind the card. This was done using NFC. So today, web can use the NFC chip that's there in your device and make a contactless communication, which is a very predominant use case, especially in the COVID and also the post-COVID eras. I really feel that NFC would become more mainstream. People wouldn't be comfortable touching devices or exchanging money, and they would like to tap a lot. And it's not it's probably have picked up in few places in the US, but throughout the world it need not be the case. And uh, this is a very good use case and an API that would be useful if you're trying to build such applications. And we could keep in mind that today web can communicate with NFC. And again, in NFC, it's not just about reading, it's also about writing. So the API again is promise based. Again, you could do a reader.scan, and after you scan through, if it is successful, the scan is successful. And on reading, it kind of gives an event which says, okay, when it's reading the particular card, like from NFC, on this event, you will be having data from the message that's been read from the NFC enabled device or card, or might be any NFC chip. And on the writer is on the similar lines. You take an NEF writer, and then you could write whatever message you want. So if you are thinking about writers, there was one cool, I would say, a device rather. It was more like a duct tape which had the NFC chip in it, so you could write to it. And me and a couple of my friends were playing with it while we were writing our personal blog and website links to it. And whoever had an NFC device could just tap on it, and it would open the browser with that URL. And that is kind of probably the digital version of your identification. These days, it might catch up to be one of that. The other interesting demo, again, yes, web can also talk to your USB devices. And here's a quick example. Here in this demo, we see that it's an Adafruit microcontroller to which we connect from USB. And we kind of try to send a message to it. Say in this case, it's hello. And it recognizes and it displays that message. And so on, how are you? And you could send messages to via USB. So basically, how do we do it? There are a few things that you could do with the USB API. So you could just do navigator.usb.get devices. This basically will list all the USB devices that is connected to your particular device, and then say, hey, look, I was able to list. This is the number of USB devices I found. This is the product name, and this is the serial number. Or if you can go specifically to vendor and product ID, if you know what USB device you're trying to access, you can say my vendor is this, my product ID is this, and you could request the device with this filter, so it goes and connects and get back with only those mentioned devices, so you can operate on them. Right? And it doesn't just end here. This example here is communicating to Bluetooth device. So similarly, from web, you can connect to a Bluetooth device, and this is showing your heart rate. That device is capable of, probably it's a wearable device that you're wearing, and a smartwatch or any other Fitbit or things like that. And you could connect to that USB like you would normally from any of your native app or any application that was previously using USB, right? So it kind of lists using Bluetooth. So it basically lists all the Bluetooth devices in its peripheral, and then says, hey, scanning for this device, I found this device, do you want to pair? Yes, the normal pairing flow happens, and there you go. Web can now talk to Bluetooth. How do we do it? We say navigator.bluetooth.request device, and in the filter we say, in this case, the service. So in the service, you could say many attributes. One of the examples I've taken here is battery service. With this, you could also get the device name. That's the human readable device name. So whatever the Bluetooth device is named as, and then you could also get the GATT attribute server basically, and try to connect to it, and you could play around with all the information, and you could control the Bluetooth device, right? I remember seeing one of the demos in one of the Chrome Dev Summits where we had an RC car which was controlled from web via Bluetooth, which was cool. The context indexing API is very interesting, and if we can relate to the background fetch example where we said, hey, you could probably download a lot of videos and save it. Similarly, in this case, it's about downloading a lot of articles or saving a lot of articles. Now, the question arises about discoverability. Your cache might have a lot of information that the user has saved previously, but when they want to use or access it, how discoverable it is. So don't think context indexing API as kind of a search API. It's not basically that. It's more about discoverability, right? Normally in your browser, you would probably go to downloads and look for everything, right? So that kind of gives you a searchable interface, but still the idea is about encouraging discoverability of what's already cached. So how does that work? So you on your service worker, you kind of register index and add with list of attributes. So you can categorize each of your content into different categories based on a particular ID. In this case, it's the ID is article 123, and you have the URL and the launch URL. That's what's cached, and when the user clicks on it, it basically opens that launch URL. So you could have multiple such entries, and you could categorize them. Here in this case, it's an article, and you have a unique ID to identify exactly what the content is. You can have a title and description. You can have icons, and they would appear, and it helps in discoverability of what the content that's already cached. So most of you, I presume that you're aware of Webrtc, technology which helps you to access your audio and video capabilities of device from web, which has been there for years. Like I think even probably even before PWA was a mainstream, and but we are getting even more closer. I didn't include that demo on purpose because WebRTC is pretty much evident, and it's not really like the future thing, but we are using the capabilities of WebRTCs, and also on the same line of accessing the camera device on, the camera capabilities of your device, to barcode recognition in this case. So we have an API, we start capture, which kind of opens up your camera. And in this case, we are detecting the QR code. So the barcode as well. Now you go and scan the barcode and it pulls up and brings up the raw data and all the information related to the barcode. Right. And this example is again very much useful when you're writing applications that would probably say you have a food sample and you want to check the barcode, you want to check the ingredients of it. You could just use Web today to scan and get the information. And it can be done in just a couple of lines. Using the new barcode detector, you could say barcode detector.detect that image, and that would kind of return you the barcodes. And from each of the barcodes, you get the raw value, which you can interpret and make sense out of it. And this is like the face detector API. In this example, we can see the early Googlers here. And when you click on detect face, it said, hey, I detected 4 faces. And these are all the metadata, image related information, their size and their coordinates and things like that. So this can also be done with just a couple of lines. You could just say face detector, and you could say face detector.detect and pass it an image, and then it would return back with faces, and then you could get all the raw information related to faces. So with Web, we are also able to do payments today. I will quickly run through a demo of payment request API. So what basically happens with payment request API is, as you can notice, it is like all the client side that gets kicked in, and we get an interface like this where you might have a saved card, or it can ask you to type in the card information, which will be saved and reused on your further payments. And it all looks and feels like a native flow, but the trigger happens within your browser. And you can also select shipping address and shipping option, and also enter your CVV or CVC, and it goes and does the payment for you and gives you information on what the payment was, what that card type was, and all of the information that can be done using the payment request API. Uh, the the interesting part with payment request APIs, it can also get integrated with third-party APIs, like if you have PayPal or Bob Pay, for example. You could use the payment request API to integrate to that, and it can communicate to that particular payment gateway and do the payment for you. The other interesting feature is the in Chrome by default, the payment gateway the payment request API can also help you to verify if the card is valid or not by, say, making a $1 transaction and then refunding you back that amount to just to verify it and validate whether whatever card information that's been entered is valid or not. So this is not really a core platform feature per se, but I thought this is a cool feature that I should just show it in this presentation. So with CSS, the preferred scheme API, like you could toggle between dark and light theme. On the left, we are seeing the demo here where we can switch between dark and light theme. This is one of the podcasts that I'm running about the future features of JavaScript as a TC39 delegate. I'm talking to a few of the other TC39 delegates as an interview on this podcast. Give it a listen. And what basically has is with media query, you can say for this attribute preferred color scheme light. This is how my background should look like, and preferred color scheme dark. This is how my background should look like. Right. So you might be asking this question. Hey, I do understand that with web, I just have an URL which I can share, and people can click on that URL and it loads whatever application that I want to use. And I can share this URL with others also, and they can use it seamlessly. But what about discoverability? Is there a single place where I can go and look for PWS? Yes, there are few such applications still made PWA in themselves, and websites where you can go and search for PWS, like PWS Store and similar. But wouldn't it be wonderful that if we could package PWAs and ship it to Play Store or any other store where an application can be installed? And because users are used to going to an application store and trying to look for application and installing them, it would be great if we can provide an ability where you could ship to that application store a PWA packaged as an application. Now the user goes and clicks on install, it installs on their home screen, and they are not aware or bothered whether it's native or web, but still it's PWA which can be installed. And today it is possible for us to ship that to Play Store. There are few websites that help you to package it. There is PWA2 APK, and there is PWA Builder, which kind of takes your PWA URL and then gives you the key and steps to upload that APK to Play Store. So that's really a cool feature in terms of discoverability, and most of the people who had a debate would probably say that, hey, I can't keep sharing an URL to all of my clients, but rather I could, if they are used to searching a Play Store, for example, that's been their pattern, that's been their behavior. No, I can't disturb that behavior or flow. And as a contrast, say if a native application is around 20 MB, there are few cases where PWA with the same functionality was just like KBs, right? So you're saving in terms of size, saving in terms of derivability, and also the discoverability is increased when you're packing it. And so this is an cool feature that many companies and individual contributors who have started using it. I wouldn't say this is mainstream, but this is a promising move. So in around 2018, I had made a few predictions that what are all the things that we will be handling soon. And some of them were like NFC, ambient light, context, SMS, task scheduling, geofencing, proximity sensor, wake clock. So most of it is in reality today. We do have ambient light, NFCs, contact pickers, we have SMS, yes. Task scheduling, yeah, probably you could say a periodic sync or background fetch, maybe. Geofencing, we haven't been reached there yet. Proximity sensors and wake lock, we do have it. And the web is really promising, and it's getting feature rich, and it'll keep getting better. So one thing that I've observed is web is taking the good parts of native and implementing it, as well as making sure that the security is not compromised. And parallelly, the native app is kind of picking up good parts from web, like when they started this concept of instant apps, right, where native apps would load instantly. Even though if you not install the native app, it would bring that part of the native app and behavior for that particular flow, which is nothing but the browser, right? When you have an URL, you click it, the browser just opens up and that page and it renders. So a similar behavior was used by native apps, and PWAs have been delivering or they're delivering all the features that a native app could have provided in terms of offline capabilities, and all the supporting APIs like what we discussed now is making web more stronger and helping us to solve many use cases that we never thought web could have solved. And it's getting there, and it's getting great. And JavaScript, in terms of how it's evolving with its new set of features, is an other story altogether, which is making web a more predominant and stronger in the future and right now as well. Is this the end of the list? I wouldn't say. There are a lot many APIs which are in the pipeline. Project Fugu is one such interesting project if you want to look into, which has a very good a sheet which kind of tracks all the features that are in the pipeline, that are in progress, that's been implemented, that's in origin trial. Origin trial is something where if you want to experiment an API that's not completely shipped on stable browsers, you can apply for origin trial for a particular domain and state your reason why you want to try it. you could add that key in your as a meta tag in your HTML and start using that API even before it goes on stable. And there are a few experimental features as well where you can enable experimental flags on your browser and try to use them. So Project Foo is one such which talks about all the bleeding edge APIs, and some of them are like can change as they progress, but it is worth looking into it. And also, if you go to git.io/awesome PWA, this is where I and a couple of my friends are maintaining a list of PWAs, which tend to use the features we were discussing about. So you can, and most of them are open source, so free and open. So you can go and read their source, try to understand their use case, and probably get influenced and write more such application yourself. And that's me. You can find me on h3man.com, and you can tweet me at gnumonth. And now I think we are open for Q&A. Yeah.
Hangout. Just unmute and ask away. We do have a question from YouTube as well. If you have any other questions, please put them in the chat. So while we wait for the first questions coming in, Hemanth, would you mind talking to us about the career path, so to speak? So I know there are a lot of students. They probably invested a lot of time learning, maybe mobile, maybe they're like experimenting with all different stacks that's out there. Where should they invest more time, or should they brush up one competency before jumping into something else? What are your thoughts on that?
Yeah, very good question. So I would start with something like what that really interests you, and I would not suggest them to just look into one aspect of it. I wouldn't say, hey, just go ahead and just do web and JavaScript, you'll be great. Or I would not say, hey, forget web and work on your iOS or Android. I would say to pot all of the things and try to find your interest, and because this is the right time and age to experiment with technology. And by experimenting, you would know that, hey, this feels pretty natural to me, or I like this more. That's one aspect of it. The other aspect is getting the fundamentals right. If you're on computer science engineering, that's good. But if you're from a different background, that's also not a problem. But unless you pick up a programming skill, try to get your fundamentals right. Like, try to know what you're doing, try to understand data structures well, try to understand algorithms well, try to dig more into the code. Say for example, if you started with Python or any other say Node.js, and you try to dig into the source code of it, because it's free and open source. Like, you go inside and try to read the implementation, try to understand and get the good parts out of it. Thereby you're sharpening your skills, and once you're kind of ready to at a stage where you are getting into the industry, you would have a lot of tools you can ask me, saying that, hey, yeah, I've also tried building an Android app, and I've also tried building a PWA, and I have a fair idea on how both of them work, right? And then you could focus on one particular thing and try to build up your expertise. On the contrast, there are a few people who also say that, hey, should we build an expertise in particular domain, or should I be more like, hey, my breadth is good, right? So you need to draw a line, and both of it is kind of good and bad in its own ways. So you need to decide. For you to reach a state where you can decide, you should have experimented a lot with technology, and this is the right time to experiment, and that is my suggestion.
Thank you for that. Okay, so we're going to take a question from YouTube. For the OTP web feature, and this is Faizan asking this question. For the OTP web feature, I'm assuming the code is being generated randomly. Random code generation pattern can be cracked. How is it secure, i.e. for banking transactions, etc.?
Okay, this is more not directly on the API in itself. So I was just trying to open the API to speak about the spec. Either way, so the question is good. So the question that's been asked here is, it's not random, but I would say why do you really feel it's random? Consider any of the OTP generation mechanism. It is pretty random. Like in the example where I showed, it was just like 4 digit, but normally OTP would be like 6 digits and sometimes alphanumeric too. So it is not like an easy hash to crack. It is a time-based random algorithm generation is being applied to generate digits. The key factor is that you can also set a timeout, right? So because it's all time bound, now I send an OTP and I expect your reply, say in 60 seconds. And in 60 seconds, no one can crack that algorithm and generate the same set of digits. That's one thing. The other thing is when I'm sending an OTP to you, I know what's the number to which I have sent. And I expect a reply from the same number. And if it's from a different number, then I'm like, hey, even though you're smart enough, you cracked it and you have already cracked the algorithm before, and you can generate the same set of digits, you can't still we can't still have break that mapping, right? So it's kind of a prone model where generation of OTP, secure OTP, is a cracked problem, and it's not open for such man-in-the-middle attacks. Hope that answers your question. I'm ready to take up any follow-up.
And if you have other follow-ups, please insert it into the chat. Next, let's take a question from the Hangout. Andrew, do you want to unmute and ask the question directly?
Sure. Can you hear me? I'm not sure how good my microphone is at the moment. Perfect. One of the big questions I had was, I know for the PWA apps, you were talking about the manifest originally, but is there anything else that you need to do to run a web app as a PWA app? And then the other thing is that for the things that you've talked about, does the user need to be running it as a PWA app for all of those different features, or do those work on the browser as well?
Yeah, thanks for the question. I'll answer the second question first. It need not be a PWA. I just took PWA as a use case to start with on how web evolved, and then try to bring in all the features. And all these features can be used independently. It need not be within a progressive web app. And how do we build a PWA? Like there is a certain set of criteria that your application should match. One, it should have manifest, then that should have service worker which is registered, and for the home screen, add to home screen button to show up, there are certain criteria again that the user should be using your application for these many seconds. They should be scrolling or being interacting with on the screen for these many seconds for the add to home screen banner to appear. So there are a set of such rules, but there's not like an hard and fast like or a difficult rule to follow. It's just that you need to have a service worker, and then any browser that supports service worker, basically. Yes, all the modern browsers support it now. And then it should be registered, and you should be able to, you should have a manifest with all those manifest related rules in terms of what your icon sizes should be and all of it. So if it adheres to those rules, you have a PWA. And there are few applications which help you to build that. Given a web URL, it would generate a PWA. It will scaffold all the manifest and give a zip which is a PWA for you. But still, when you're building a PWA by hand, you should be mindful of following the best practices of web, like having an application shell, having lazy loading, and maintaining your bundle size well, seeing that you don't have unused CSS on your page, and seeing that you're not blocking the main JavaScript thread, and some fundamental principles of web.
Okay, thank you.
Yeah, no problem.
Questions from the Hangout? Anybody want to unmute, ask Hemanth? If not, Hemanth, I want to get some your thoughts on this. So if you look at the demographic that's growing when it comes to mobile and connectivity, it's the developing countries. But the problem is they all have issues when it comes to the infrastructure or being able to acquire a mobile phone with all the smartphone, for example. Do you think, after looking at all the items you listed out, if an entrepreneur or even a company to build their whole ecosystem on um, 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 the web, is that possible? Do you see any issues that they're going to run into in the future, or do you think it's scalable and sustainable?
Yeah, definitely it's scalable and sustainable unless and until you have a very hardcore case of you can't find an alternative or you find an equivalent web API that you're trying to do on native. It is definitely sustainable, and I've as a part of Launchpad mentorship program in Google, I've mentored a few such startups which just had PWA and they have been very successful. So, to coming back to your question, where there are few countries which, say, for example, India, where it's building, it's more like building to the next billion, where there's a set of population who just saw the internet only on their mobile device, right? They didn't mobile device and sometimes on mobile web, and few countries where they're having mobile devices which are not like uh, very capable in terms of memory and storage. And especially for cases like those, PWA would be a very meaningful uh, application, because you're like adding it on your home screen, it behaves and acts like native application, as in it can work offline, but still it's not consuming a lot of space, and that's where it's a big winner.
Interesting. Thank you for that. Any other questions? If not, I got one more question for you.
Yeah, and before that, I just wanted to add again, as we highlighted at the very beginning, this is more like an overview of all the APIs, right? So the viewers who have listened, like if they're interested in a particular API or they want to do a deep dive in one of these APIs, in the upcoming workshop, if we whenever we plan them, we could do an hands-on session as a workshop and use those APIs and build some interesting applications. Or if they want to build a PWA, we could have that as a different session and we could build PWA by hand.
I'm going to tee up too. I think WebRTC is something interesting given what's happening right now. And that's what I was going to suggest. I think that and the security side would be something that we would love to explore, and I'm opening this up to everybody to see what their feedback is, what ideas they have. But looking at what's going on, what requests we get, this would be an awesome thing to kind of kick things off.
Yeah, as you mentioned, WebRTC, the interesting thing that's happening with WebRTC latest on the specification is there is an introduction of speech recognition as part of WebRTC. We already had speech recognition on the Navigator, like not as part of WebRTC. Now we're also having that as part of WebRTC, which can result in many variants of applications, right? Like for example, you can have something like a live translate where I'm talking on my in a different language and it gets translated to a different language, and possibilities are many.
Any questions? I'm going to open it up to one or two, maybe. If not, much everybody. Thank you for joining. We're going to have this session live on YouTube in a few hours. Special thank you to Hemanth for taking the time off and educating us on what web is capable of. And we're going to schedule a few more of those sessions on some of the topics he highlighted. And we would love to see what the capabilities are. And hopefully we can do some of these sessions very much more interactively, where everybody get to ask questions as he goes through the content. So stay tuned. I'm going to follow up with everybody with an email with the content pieces and the other upcoming emails that we have listed. So that being said, Have a great evening, and see you guys soon.
Awesome. Thank you.
Bye.
Bye.